standardly used these days for prosthesis users is prosthetic liners. So these are a soft silicone item that's worn over the skin. It increases comfort greatly and is ubiquitous in high-income settings now. Problem being with them is that they only come in these standard sizes. And as if your residual limb, your type of amputation or limb difference is not standard, then you can't use these. There's ways to get around that. We've been looking at molding techniques, as have other groups. This is available. We can mold, 3D scan, print, mold liners for these people. But if we want to do anything more exciting and embed different technologies, of which there's a range of things that we could be doing, molds aren't really going to work. We need to be printing these devices with those technologies inside at the same time. So there's a range of more advanced functionality that we'd love to be embedding into prosthetic liners or any other device that interfaces with the skin. But we need to be able to be printing these as one. So to achieve these different functionalities that we dream of at these 3D complex geometries that we want to achieve a few different things with the printing rig that we're looking to develop with this project. So in the first instance, we need to be able to print those super soft materials in complex 3D geometries, and we do that by developing a syringe printing rig that will print directly into a supportive gel bath that will hold its structure while we're printing, and then we'll be able to leave it and let it cure. What that means is, compared to some other soft printing technologies, is that we've got total choice over what material we put into that syringe, and we can make decisions based on the end outcomes that we want in the product. Once we've got that set up, we also want to be bringing in options of multi-material printing within that same structure. So looking at potential routes with coaxial syringe printing, we can then be able to ratiometrically control different materials and deposit them at the same time, so we can be building sensor structures or different stiffness gradients all at the same time within this bespoke production rig. So we hope that the impact of this project is that the exciting different functionalities that we can hopefully achieve with prosthetic liners and other soft technologies against the skin will be opened up to people that have complex needs. As well as this, we hope that through different material choices, we could be making products more durable and more affordable, and hopefully then therefore be able to be reaching people that we just couldn't reach with these technologies any other way. So here we're often focused on prosthetic liners, but realistically this technology could be used for any arena where we want complex, super soft devices, particularly that are up against the skin. For the range of wearable technologies that are coming through now, different functionality that people want on their bodies, it could be opening up avenues for that. So this could be a lot of different things. Areas like scoliosis bracing, where actually the forces that are being applied to the body are changing. That could be being tracked. In sports, in sports science, we really don't have a great deal of understanding about what happens between devices and people at this point. It might be opening up that kind of analysis. Equally, where people are in contact with a device for a prolonged period of time. So wheelchair users or bedridden patients, and trying to monitor their skin health. This could be open avenues for devices applied to those areas.